Okay, again, my name is Mr. Tolentino, and I am now going to discuss the fourth lesson in the differential equations course. This is solution of first order of ordinary differential equation, and we have this first type is the simplest of the differential equation, that is variable separable. Let us define what is a variable separable. A first-order differential equation of the form dy dx is g of x times h of y. Notice that the differential equation can be expressed as a function of x, a product of a function of x and a function of y, is said to be separable or to have separate variables. Now you can simplify that. You see that you can divide both sides by h of y, and this is dy over h of y is g of x dx, and then the variables are separated, and this can be integrated already. Let's have example 1. Alright. Now, is this variable separable? So let's see if we can express this as a function of both x and y, or a product of x and y. Now here you see that this is the original problem. Okay, then you see that e to the 3x times e to the negative 2y can be what? Can be simplified into e to the 3x times e to the negative 2y. These are this can be expressed already as what? Functions of x and y. You see that x squared e to the 3x, okay, that can be what? That can be combined, and then y squared e to the negative 2y is combined, and therefore this is what? This differential equation is what? Is variable separable, like this one. Okay, is example 2. Now here, this is a non-separable differential equations because you cannot express y minus sine x as what? As a product of two functions of x and functions of y. So let's have one example. Solve this differential equation dx dt, okay, equals t squared minus 1 over x. Obviously, this is variable separable. Okay, this is a functions of both x and y and can be separated. Okay, the next step is, this is the original problem. Okay, just multiply, cross multiply there. You have what? So you have the cross multiply it there. You have x dx equals what? T squared minus 1, and integrate both sides. What you see is, okay, so you have what? Integral of x dx is integral of t squared minus 1 dt. These are simple integration. Integral of x dx is x squared over 2. Integral of t squared is t cubed over 3 minus integral of 1 is negative t plus c. Okay, so this is our what? This is our final solution, which is the general solution of the D. Next is, let's have example 4. Okay, solve x plus 1 y dy plus y dx is 0. This is variable separable. Actually, we can just divide that both sides by x. Okay, x plus 1 times what? Times y. Okay, once you do that, once you do that, you have what? dy over y na lang, okay, and then what? Dx over x plus 1. Then you can integrate both sides there, integrate both sides. What's the integral of dy over y? That's ln of y plus ln of x plus 1. The integral of 0 is a constant. You can combine that using the properties of logarithm. Product is the addition becomes a product of the logarithm. This is ln of y times x plus 1 is c, and then removing the ln, okay, raise e to the both sides. You have e to the ln of y times x plus 1 is e to the c, and then our what? And then our final solution is y times x plus 1 is c1, where e to the c, okay, is just equal to what? Is just equal to c1, because this is originally e to the c. Now sometimes it's simpler for you to get this c again, c right away as ln of c, like in the next, okay, instead of c, put ln of c there, so you don't have to go to this process. Then you can do the properties of logarithm. This is addition, this becomes a product. Ln of y times x plus 1 is ln of c. This involves both ln, so what is inside is the same. Therefore, y times x plus 1 is c. This is our solution. It only matters in the how you represent the arbitrary constant. It can be c, c1, c2, c3. It will not matter. Next, let's do example 5. Now, solve dy dx. Okay, solve dy dx equals y cosine x times 1 plus 2y squared. Obviously, this could be written as a product of what? Two functions, y times 1 plus 2y squared times cosine x. And this is variable separable. So, okay, this is the original problem. Alright, just cross multiply it. Okay, just cross multiply it there. Okay, so, and then what? And then divide by y. So you have what? Y squared minus 1 over y dy is cosine of what? Is cosine of x dx. And then integrate both sides. Okay, so this is a basic integration only. Of course, this can be what? This can be y over y is the same as y, and then negative 1 over y, that is negative 1 over y for the integration, and then integral, and then dy. Okay, so dy, that is okay, that is our what? Our, okay, so the next step is integrate, that is just one. Y squared over 2 there, y squared over 2 minus ln of y is what? Sine x plus. Then you can, okay, I think this is now the final answer. If you want to multiply that by 2, then that would be y squared minus ln of y squared. Notice that this becomes negative 2 ln of y. Ln of what? Ln of y. Okay, that's why it becomes negative ln y squared minus 2 sine x. Sine x was transferred there, is equal to 2c. You multiply both sides by 2, and that's just equal to another constant c1. So we can have this as our general solution. Let's have the next example. This is now an initial value problem, because there is an initial condition given, that is y of 4 is 3. Now, okay, the meaning of this is just when x is what? When x is equal to 4, okay, then y, just y is what? Y is negative 3. So, okay, so this is now what? This is now the solution. Okay, we have dy dx. Okay, we have dy dx is negative x over y. Now cross multiply this, that is there and there, y dy equals negative x dx. And then integrate both sides, that's integral of y dy equals negative x dx. And then what? The integral of y dy is 1/2 y squared, and the integral of x dx is negative 1/2 x squared plus an arbitrary constant c. Now multiply both sides by 2, you have y squared, and then transfer x squared to the left, y squared plus x squared equals c1. Where of course this is originally what? This is originally 2c. This is originally 2c, and then that is just replaced by c1. Okay, and then remember that we need to find what? We need to find the value of C1 based on this initial condition. Uh, just substitute what? X is 4 and y is negative 3 in this equation there. So you have negative 3 squared plus 4 squared is C1, and therefore we have C1 is 95, and then plug the value of C1 here. So plug the value of C1 there in C1. So you have the final equation, y squared plus x squared equals 25. This is what we call the particular one, particular solution, because you have a value of what? You have a value of arbitrary constants. Next we have, this is already example 7. So this is already example 7. Solve dy dx is 3x squared plus 4x plus 2 over 2 times y minus 1, where y of 0 is 1. Again, this is an initial value condition. That is, when x is 0, you have to substitute what? Y equals negative 1. In order for you to determine the value of the arbitrary constants. So, our solution, this is the original problem, okay? So just cross multiply that. So the variables are separated automatically. So 2y minus 1 dy is 3x squared plus 4x plus 2 dx. The variables are separated and integrate both sides. Okay, so this is twice of y minus 1 integral is integral of 3x squared plus 4x plus 2. Okay, so next step is, what's the integral? Integral of y is 1 half minus y squared minus y. That's integral of 3x squared is x cubed plus 2x squared. That's the integral of 4x is 2x squared, rather 4x squared over 2. That's 2x squared plus 2x plus c. And this is already our what? This is already our general solution. So this is our general what? General solution. Okay, our general solution. We need to find the value of c. So how do we get the value of c? Well, here, okay, this just simplified into y squared minus 2y, and then transfer, okay, transfer the x cubed, 2x squared, 2x there to the left. This is our what? This is our general solution. Then to find the value of c, then you have to what? You have to substitute this initial condition. When x is 0, y is negative 1. So solve for c. Okay, this is our original problem again. Okay, so substitute the value of what? Y is negative 1, that's y is negative 1 and x is 0. And you see that the value of c is what? C equals 3. If you know the value of c, okay, then we can what? Then we can plug it here in this equation. So what do we? So our particular solution now is this one: y squared minus 2y minus x cubed minus 2x squared minus 2x equals 3. This is now the particular solution. Next is, let's have the last example. This is already example 8. Okay, we have ds dt. ds dt is s squared plus s over t squared minus 1. Again, our solution, let's rewrite the original equation, that's what. And then separate the variables by simply what? By simply, okay, moving s squared plus s there and moving dt there. So this will be your problem. Okay, and then integrate both sides. So notice that these are no simple integration because this would require integration using partial fractions. So this one you can factor s squared plus s as s times s plus 1 is dt over t plus 1 times t minus 1. Now, okay, I need this integral there. Okay, I use partial fractions here. So 1, this one. Okay, these are This will have linear what? Linear partial fractions in the numerator. So this is a over s plus b over s plus 1, and multiply. Okay, this will simplify to what? To 1 equals a. Okay, 1 equals a times s plus 1 times ds. That is upon multiplying by s times s plus 1. Now remember, this is an identity. To solve for a, I only have to plug s is what? S equals 0. So if s is 0, then 1 is equal to a times 1. Then a is 1. If I plug s is negative 1, this will be removed here in the equation. So 1 is b times negative 1, therefore b is negative 1. So that means this is 1 and this is negative 1. So my only problem is this one. Okay, so for that problem, okay, for 1 over t plus 1 times t minus 1 equals a over t plus 1 plus b over t minus 1. That is again constant in the numerator. So again, this multiply both sides by t plus 1 times t minus 1. This gives you what? 1 is equal to a times t minus 1 plus b times t plus 1. Again, this is an identity. In order for you to what? In order for you to get a, then substitute t is negative 1 here to make this 0. Therefore, 1 is what? A times negative 1 times negative 1. And therefore, the value of a is negative 1 half. And to eliminate a there, plug t is 1 to make this 0. So when t is 1, 1 equals, this will be 0. Okay, b times 1 plus 1 there is 2, and then b is 1 half. So that means we have, this is negative 1 half, and b is what? 1. So we are now prepared to plug it in this equation there. So our final equation now is, okay, we have what? 1 over s minus 1 over s plus 1 ds equals the integral of our a is negative 1 half over t plus 1 plus 1 half over t minus 1 ds plus of course an ln of c. You may notice why I put an ln of c here, because if you notice, all of these integration will produce ln's. So it will be simpler for us to put an ln there, and then we can get rid of that ln as we simplify. Integrating now, you get ln of s minus ln of s plus 1 equals negative 1 half ln of t plus 1 plus 1 half ln of t minus 1 plus ln of c. Okay, multiply this by 2. We have 2 ln of s. This in order for you to get fractions there. Negative 1 half and 1 half. Then you have 2 ln of s minus 2 ln of s plus 1 is negative ln of t plus 1 plus ln of t minus 1 plus twice ln of c. Okay, so simplifying, we have what? Ln of s squared, and then this is a quotient. This is a quotient, okay, over what? S plus 1. Okay, this is actually what? This is actually, there should be a square there because of what? Okay, because of that factor there, 2 ln of s plus 1. This is a quotient. Is ln of t minus 1 over t plus 1. This is a what? This is a quotient again. This is a difference times c squared. This is a product now. 2 ln of c is c squared. This is product. This is quotient. And if you let c squared is c1, then our final solution will be what? Okay, s squared over s plus 1 squared is equal to c1 times t minus 1 over t plus 1. This will be our final one. Okay, this will be our general solution. Alright, this will end my discussion of variable separable. Thank you and good day.